Welcome to this maths video brought to you by Vision Concept Academy. In this video, we'll be looking at sequence and series. Video is tailored towards those preparing for WAEC and JAM exams. Right. What is a sequence? A sequence is a set of quantities that is defined, that has a defined order. Example, if I have this kind of quantities 1, 3, 5, 7, and so on. This is a sequence. Another sequence could be 2, 6, 18, 54, and so on. So for sequences, there's a defined order. There's a defined order. Another one, 2, 4, 6, 8, 10, 12, and so on. It's a defined order. That's a sequence. It could be finite or infinite. But a series is a sum or the sum of the terms of a sequence. So if this is a sequence that each term is divided by comma signs, that is comma signs separate them. Now for series will now be addition of all these terms. Example, this first one, for it to become a series, it becomes 1 plus 3 plus 5 plus 7 and so on. So this is a series. Why these are sequences? Examples of sequences. So these are series. So this one becomes 2 plus 6 plus 8 plus 54 and so on. So these are series. Now for our level of discussion, we'll be having two types of series that we'll discuss. Types of series that we'll discuss. We'll look at arithmetic series, and geometric series. So these are the three that we're going to look at. So the first one is arithmetic series. So we look at it and know what they are and how to identify them, how to solve for them. So I'll just put on the board like this: arithmetic series or progression. Arithmetic series. So example of arithmetic series, or let me say progression. Let me start using the word progression. So it's a series. Arithmetic progression. Most of the time you see A, P. Please don't add C to it too. So that it won't look like political party, but this is AP. AP is arithmetic progression. Example, if I have 2 plus 5 plus 8 plus 11 plus 14, this forms a kind of AP. So it's continuous. I just put plus here and continuous. Now, by inspection, if you look at it, what comes to your mind? How is this number changing? First of all, this number changed from 2 to 5. Then the next time again, I'm seeing 8, I'm seeing 11, I'm seeing. So in this series, I can see that it's what they call the first number or first term. The first term, let's denote it by A. Every time we denote by A. And the first term is the one that starts it. So that is the first term. Then 2, after 2, I have 5. What's the difference between 5 and 2? There's a 3 in between the two of them. And 5 again and 8, there's a 3 again. So I can see that these terms progress by adding 3 to the previous term. So if I start with the first term and add 3 to this first term, I get 5. Consistent. If I add 3 again to this 5, I get 8. If I add 3 again to 8, I get 11. If I add 3 to 11, I get 14. Now, this 3 I'm adding up and down that's very, very constant. It's what we call the common difference. The common difference. Common difference. And we denote common difference with the letter D. Common difference. And you can also decide to make this series stop somewhere for analysis, because this series is going to continue as long as number in counting never ends. Just keep on counting. I don't think I've ever thought about the when the counting will stop, when numbers will stop. I've not thought about it, but maybe because we don't have what to quantify the last number. So numbers are actually infinite. We don't have what to quantify. If you want to count everything in this world or in this universe, there is a number to denote it, and even more. So if we want to stop at a particular point somewhere for analysis, we can call that point a term, the end term. The end term. So we don't just continue counting. You understand? We don't continue counting. So it means that I can decide to say I want to analyze between 1, 2, 3, 4, 5. That is for e.g., fifth term. You understand? Where I stop is the term. So we denote the number, the end term by n. So any time you are asking the question for a particular term, it is n. If it is the sixth term, n there is 6. If it is the fourth term, n there is 4. So these 3 basic parameters are the things that we use to analyze arithmetic progression. So if you can check what is happening here, if I want to use this thing to denote what's happening, I can see that my first term is a. That is this one, is a. Then plus this second term, to get this 5, it is actually a plus d. That's the second term. Why? Because if I add, this is 2. If I add 3 to 2, I get 5. And my third term is a plus 2d. How? If I add, this is 2d, d is here is 3. D times 2 is, 3 times 2 is 6. 6 plus 2, which is the first term, is 8. So you see that by the time I continue, I'm forming a formula already. This is 3. And so on. Continue. The next term now, here I'll have 4. So there is a formula or a pattern that is evolving. So if we want to get the nth term, for instance, the nth term, that's what I said here, the nth term formula is a plus n minus 1 times d. Please note this, very, very important. Let me rule it, let me box it. Very, very important. The nth term, where a is the first term, n is the number of terms that you are considering, because you specify it, and d is the common difference. So they say you should find the nth term. For instance, in this series, I have 1, 2, 3, 4, 5. The 6th term is the next one. I can say, let us find it. I know that we know it already from this thing. Just add 3 again to this now. Let's leave it blank first. But I want this formula to find the next term. 1, 2, 3, 4, 5, 6. That is 6th term. So the 6th term is equals to a is 2 plus n is 6. Why? Because it's the 6th term we're looking at. 6 minus 1. And d is 3. So 2 plus 6 minus 1 is 5. 5.3, that's 5 times 3. 5 times 3 is what? 15. 15 plus 2 is what? 17. So that's the 6th term. So if I add 3 to this one now, it's 17. So you can actually do formula, because a time will come when they will just give you only the first 4 terms. Has to go and find the 34th term. Will you start adding the common difference until you get to 34? That's when this formula will come in. All right, so we'll move on to the next one. We are going to look for derive a formula, or I will give you a formula that talks about the sum of all the terms, or the specified number of terms. So the sum of first n term, sum of first n term formula, sum of first n term. Okay, so I'll put it like S. Nth. S is sum, nth is the number of terms. So sum of the first nth terms is equals to n over 2, open bracket, 2a plus n minus 1, close bracket, then d, close bracket again. Please, this formula is the formula for the sum of the first n term. Note how it is arranged. There's a small bracket in between here, inside here, there's a bigger bracket. So you can work on this one, times this one, add to this one, then whatever we have here, you now interact with what we have outside. Please take notes. So we're going to be doing examples quickly. Examples. So note this formula, the first one I gave you, and this one. So I can still take this one off, and we are still dealing with arithmetic progression. So we said that the features of arithmetic progression is that there's a common difference, there's a constant number that adds to the terms to increase it to the next term. So if they say find the sum, find the sum of the first 20 terms of the series. So I have 10 plus 6 plus 2 minus 2 minus 6. This is a series. This is a series. So the actually stopped at this 1, 2, 3, 4, 5 at the fifth term. So we should now go and find the sum of the first 20 terms. So S20, which is sum of 20 terms, is equals to n over 2, n over 2, n over 2, open bracket, 2a plus n minus 1, then d, all brackets. Okay, so at this point, we need to know what we are looking for. What's our a? Let's define our term. Our parameter a is 10. What's our d? Our d is this one minus this, or this minus this. Note how I'm going. It is the higher term, or the higher term, yes, or further term, minus the preceding term. That's the term that comes before it. Don't say 10 minus 4, or sorry, 10 minus 6. Don't do like this. Don't start from it again. Start from, let this one be the last one. 6 minus 10 is minus 4, or 2 minus 6 is minus 4, or minus 2 minus 2 is minus 4, and so on. So the term d, common difference, is minus 4. And finally, n is what? 20. Once you have gotten these three parameters, you are done. You are done. Just substitute. So S20, that is sum of 20 first 20 terms, is equals to n is 20 here, 20 over 2, open big bracket, 2 times 10, that's 2a, plus n, what's n again? 20 minus 1, then d is what? Minus 4. Note all these signs, and be careful with your notation. This is now multiplication, not the decimal. Okay, so S20, that's sum of 20 terms, is equals to, this is 10, that's 20 times divided by 2 is 10, then open bracket, 2 times 10 is 20, plus, this is 20 minus 1 is 19. 19 times minus 4, 19 times minus 4 Please just note how this thing is going progressively. So by the time you do this calculation, I have minus 76 here, minus 76, and then 20. Okay, then times 10. S20, that's sum of first 20 terms, is equals to this. So sum of first 20 terms is equals to 10 times minus what? Minus 56. And sum of first 20 terms, let me come here, is equals to minus 560. So this is the sum of the first 20 terms. So just note how this works. The formula, first of all, read the question, bring out the parameter, write out your formula, put your parameters given into the formula. Sometimes it's just all about algebra and mathematics. Once you can get the question and the formula, sometimes they can even give you this parameter, and ask you to find the missing one and the ungiven one. So we are dealing with 1, 2, 3, and 4 parameters in this sum of terms. You understand? So out of the 4, they will give you 3 to find 1. In this case, we're given these 3, 1, 2, and 3 to find this one. Sometimes they can give you this one, this one to find this one. So they must give you, out of the 4, they will give you 3 to find 1. So when you have gone to this point, what is left now is just to do simple algebra, simple subtraction, addition, correct like terms, divide both sides, all those things, yada 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 yada. You understand? So that is for this first example. Let me solve one example again. Under arithmetic progression. So we solve this example like this. Okay. So set number 2. If the nth term of an AP, what's AP? Arithmetic progression, is 22, and the 12th term is 37. Find the series. Find the series. Find the series. Find the series. Okay. So this is what we are given. So let's look at it. Let's look at it. Okay. So if the nth term of an AP is 22, the nth term is 22, and the 12th term is 37, find the series. Find the series. Okay, I need to change my marker. All right, so the nth term is 22 of an AP. So how do we get the nth term? Nth term formula is A plus n minus 1, then D. So if the nth term is 22, so if I'm looking at 22 here, for instance, so I have 22 is equals to A. I don't know A, but I know n as 22 minus 1. I don't know D. So I have 2 variables that are missing here. So I'll write this properly. I'll say A here plus 22 minus 1 is 21. 21. D is equals to 22. So I have 2 missing variables here. So I'll call this one equation 1. Two variables are missing. So the next definition here, they said, and the 12th term, 12th term is equals to a plus 12 minus 1d. So as I'm going to say a plus 11d is equals to 12, equation 2. So there are two equations in this question. Equation 1, they say is the 22nd term. The nth term is 22, and the 12th term is 37. Okay, so we should find the series. Okay. Okay. So if the nth term of an AP is 22, the nth term is 22, and the 12th term is 37. The 12th term is 37. This is also 37 here, please. The 12th term, 37. Why, if the nth term of an AP is 22? 37. So it's 37 here. The 12, so this is 12 here. Uh-huh. 37. Okay. 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 Sorry, the question is wrong. It's supposed to be 7th term. 7th term of an AP. So this is the question, not n, 7th term. So this is supposed to be 7 here. I will explain this very well, please. I got the question wrong, that's why I put this like this. Okay, so this is 7. Very good. Very good. So the two equations are, this is 6, sorry. Okay. So these are the two equations. Equation 1 is A plus 6D is equal to 22. Equation 2 is A plus 11D equals 37. So the question, I did put the question correctly. If the 7th term of an AP is 22, so the 7th term is 22. That means if I write 22 is equals to A plus, when I see N, I put 7 minus 1, D. D is not given. 7N, N is given as 7. And the number, the term inside that 7th term is 22. That's why I have 22 here. So at this point, I now have 22 is equals to A plus 7 minus 1, then close bracket D. So I can rearrange this one. This one comes to this side. A plus 6D is equal to 22. So this is equation 1. And equation 2 now is A plus 12D, 12 minus 1 is D. Then this one can come this way. A plus 11D is equal to 37. So these are two equations. So what we need to do now in this particular example, you are given a question that produced two equations. Why? Because at the first instance, A and D was missing. The first instance, what the first instance? 7th term. They gave you 7. They said they specified 7th term, and they gave you what is 7th term. You understand? Now this formula will work, but there is no first term. There's no common difference. Second instance, 12th term. They gave you they say it's the 12th term. You understand? And they gave you what is the 12th term, which is 37. And you can do it like this, but you don't have A and D. Now it's the same A that is in this instance, that is in the second instance, and the same D in the first instance. So you can now solve this like a simultaneous equation. Now I can from equation 1, I can say from equation 1, I can now make A subject. A is equals to 22 minus 6D. I will call this equation 3. So I'm going to put whatever I have in equation 3 in equation 2. So substitute in equation 2. Substitute in equation 2. Where's equation 2? Is equation 2. So wherever I see A, I just put this one. 22 minus 6D, that is for A, plus 11D is equals to 37. So I can solve this one. I can solve it. Let me go up here and continue. So this D, 6D minus 6D plus 11D on this side. Minus 6D plus 11D is 5D. And 37, this one will go out to meet it. 5D. 37 minus 22 will give me 15. So I have 5D is equals to 15. So D, divide both sides by 5 to give me 3. So I've gotten the common difference. So I can now go ahead and substitute D is equals to 3 in equation 3. See how I've marked my equation so I can know them. I can put 5, D is equals to 3 into the equation so I can get A. So substitute D is equals to 3 in equation 3. So equation 3 is A equals to 22 minus 6D. So A is equal to 22 minus 6 times 3. So A is equals to 22 minus 18. A is 18 clearly. A is equals to what? 4. So I've gotten my A as 4 and my D as what? 3. At this point, I can form my series. Say, find the series. So the series, if A is the beginning of the series, the series is A plus, I will now add 3 to A. So I have 7 plus 10 plus 13 plus 15 and so on. I write the series. They didn't tell us when to stop. They tell us when to stop. This is not 15, this is 16. I'm adding 3 to it plus 19 plus 22 and so on and so on and so forth. All right, so we'll stop here for today. I will encourage you to practice more. Practice. We'll have another video where we'll look at more examples and we'll also go into geometric progressions. So I hope this has been informative for you. Please like and share and subscribe to our page if you have not subscribed to our channel. Thank you for watching.